Hey, welcome back, and in this series we are deep diving in what happens under the hood in the V8 engine, what happens to your JavaScript when you've created it and then it gets parsed into an abstract syntax tree and then eventually turns into that bytecode, that virtual machine code that is eventually going to be turned into a platform-specific code that will either run in your browser or run in nodejs in your backend. We're going to focus in on the bytecode, so you're going to understand all the things like accumulators and registers, etc. And then, in fact, in a previous video, we covered all of that, so we're not going to cover that right now. But if you look in the top right-hand corner, you will see a link to that video where you can really get into the depths of those details. Now, where we left off is we had a pretty good understanding of what was going on with registers and what was going on with accumulators. And what we're going to look at now is understanding with your functions what happens with parameters. So what I want to do is go back to VS Code for a second. We'll do a bit of a refresh of what's happening under the hood, and then we'll see what's happening with parameters. So if I fire up VS Code for a second, I'm going to delete this and we'll sort of create it from scratch again. So we're going to create a new function, and we're going to call that function add2numbers. So we're not going to pass any parameters just yet. And what we're going to do is we're going to have a constant called n1, and we'll set the value to 10. We'll have another constant, and we'll set the value to 5. And then what we're eventually going to do is add these two numbers together. So n1 plus n2. And then we'll log it out to the console. So we'll do a console.log, and we'll add n1 plus n2 together. Okay, and let's just save that. And if we go to my terminal for a second, let's clear this. And if I run nodeexample.js, you will see I have done a terrible job because oh, I'm an idiot. So if I do a console.log to add two numbers, and then we'll just bracket that, and then we'll go back to the screen. Let's run that again. And now it should work, and it returns 15. So what we are going to do now is we will have a look at the bytecode that's generated. So to do that, all we're going to do is add in the flag --print -bytecode, and that prints out the bytecode that's generated by the interpreter. And then we're going to filter on a function add2numbers. So that's the function that we just created. And then, of course, it's going to run example.js, which is our file. So if we run that for a second, it's going to return that bytecode. As a bit of a recap on the previous videos, if you don't understand that, that's okay. Have a look at the previous video and this will all make sense. But essentially what's happening underneath the hood is we have this thing called an accumulator, which is a special register that is used for arithmetic. So any arithmetic that happens in JavaScript virtual machine. And again, it's an old concept that comes back to even 1940s with Alan Turing, etc. But essentially, that's the thing that does arithmetic. So this first statement is basically saying load an integer, so a small integer, and it's going to load the number 10 in there. So you see that there. And then it's going to load that into this thing called the accumulator, which is this special register for arithmetic functions. And that accumulator stores any value that that you're using as part of your calculations. And then what's going to happen is once I've loaded the number 10, and then this next opcode is going to say store whatever's in the accumulator into register 0. So we have this other thing, these other registers. So we have one called register 0. So the accumulator is very, very fast. It's used for arithmetic options. But then if I want to store some numbers, I need to store that in a register for retrieving later. So in this case, we have R0, which is register 0. And for every declaration that I make in my in one of my functions, then I need to have a corresponding register. And again, it's all explained in the previous video. So in this case, because I've got a constant n1 is going to map to register 0, and the value 10, which is in the accumulator just now, is going to be stored there. Now, the second thing I'm going to do is then load into the accumulator the number 5. So it's the same call that was made before. And then it's going to store in the register the value 5. So that's cool. So it's going to store that in register 1. So now my accumulator is going to have the value 5 in it. Register 0 is going to have the value 10, and register 1 is going to have the value 5. And then what's going to happen is we're going to load into register 1 the value 5 again. So 5 is in the accumulator. And then we run an addition. So what an addition does is it adds to whatever is in the accumulator at that point in time, which is going to be the value 5 because we just loaded that from register 1. And then we will add whatever is in register 0. So that's the R0, which is 10. We'll add that together and that will be 15. And then what we're going to do is return whatever is in the accumulator at that point. So we're caught back up again. Again, if I've ran through that really quickly, you can have a look at the previous video that I did where I spent a long time getting into the depths of what all of these instructions are. So now that we've had the recap, let's get back to business. So if we have a look at our header here, we can see that associated with this function add 2 numbers, we've got 2 registers. As I said before, every declaration that I make is going to have a register associated with it. But I also am going to have a list of my parameters. So you can see in this case, I've got a parameter count of 1. Now, I don't have any parameters in my function at the moment. So actually, if I go back to my code, you can see I've got N1, I've got N2 there, my 2 registers, but I don't have any parameters. So why does it think it has parameters? And basically the answer is your return value is being considered as a parameter. So the first parameter is always what you're going to be returning from your function. So in this case, we're returning what is in the accumulator, which is 15, and therefore that's what's returned, and that's what that parameter is. So we're always going to have a parameter there to represent that function. But if I were to then start adding some parameters to this, then you're going to see that number increase. So let's do that. Let's go back to Visual Studio Code, and then what we will do is add a couple of parameters. So actually, we could get rid of N1 and N2 if we wanted to. So why not? Why not? Let's do that. Let's just put N1 and then put N2, and then we'll just get rid of them. We don't need them anymore, and we're going to pass in the values we want added into the into our parentheses here for add 2 numbers. So let's stick in 10, and we'll put a different number this time. We'll put 20, right? So we're going to have hopefully have 30 returned. So that's been changed. If we go back to our terminal for a second, and then if we just run the code, it is going to return 30. So it's all working. Our code is good. But let's have a look at the bytecode that has been created. And what you're going to see here is with my new code, my register count is 0 because I've got rid of my 2 constant statements from before. And what has happened is my parameter count is increased to 3. And that makes sense because if I go back to VS Code for a second, you can see I've got 2 parameters, N1 and N2, and I've got my return parameter, which comes back when I do my console.log. So I should have 3 parameters. Now, if I look at the actual bytecode, there's no new instructions, which is really good. So the first instruction that I've got is LDAR, and then it's A1. So I've seen the LDAR command before, which is load into the accumulator. So LD stands for load, A stands for into the accumulator, and R is register. So load into the accumulator from the register A1. And A1 is representing my parameter. So it's loading that first parameter that I specified. And then the second thing that it's doing there is you can see an add. We saw the add command before. So it's going to add to whatever is in the accumulator. So the value of A1 is currently in the accumulator. And then it's going to add A0. So that's going to be the first parameter. So I passed in, if you remember, I passed in the values 10 and 20. So 20 will be in the accumulator, and then it's going to add 10 to it to get my 30. So if I come back to my terminal, and then you can see it's just running the return again. So, and we can represent this on the iPad again. So what we're going to do is we're just going to run the bytecode again on paper like we did before. So let's create a table on my iPad. So I'm going to have an instruction column like we did before. And I will also have a column to represent accumulator. And then we will have a column for A0. and we'll have a column for A1. So that is going to be our table, and we'll just run through the instructions on paper like we did before. So the first instruction is, actually, before we get to that first instruction, let's just see where we are at the beginning of the function. So it's not a real instruction, but I just want to set everything up. So at the beginning of our function, accumulator is not set. There's nothing in there at this point. And then in A0, we passed in the parameter 10, if you remember. So let's set A0 to 10. And then, of course, if we remember what we set for parameter 2, so that was 20. And let's just confirm that. If we flip to VS Code for a second, you'll see add two numbers, 10 and 20. So that 10 represents A0, and that 20 represents A1. Let's come back to the iPad. So accumulator is empty at the moment. There is nothing in there. So what we're going to do is run our first instruction. So we've seen this instruction before. It's ldar A1. So LD stands for load. A stands for accumulator. So load into the accumulator the value that's in the register that I specify. So in this case, it's going to be A1. So load into the accumulator whatever is in register A1. Okay. So A1 is currently set to 20, as we can see there. So let's just update our A1 and A0 registers, and we're going to load whatever's in A1 into our accumulator. So our accumulator should now be set to 20, which is cool. And then the next command that we've ran is add AO. So let's put that in here. Add AO. And then, of course, there's that little bit of goop at the end, which is used for optimization, but we're going to ignore that. Yep. So let's have a look at that command. So add means add to whatever is in the accumulator just now. So the accumulator is currently set to 20, and it's going to add whatever is in A0, right? Which is 10. So it just adds that and then stores the intermediary value. So accumulator is now going to be 30. AO, of course, is still 10, and A1 is still 20. And then the final command is return. And what the return command does is returns whatever is in the accumulator at that point in time. So we should be returning 30, yeah, and none of that changes. And therefore 30 comes back. And that's exactly how it works. So none of these commands are new. They're all what we saw before. What is new, though, is that rather than having R0 and R1, we've now got this AO and A1. And actually, I can then sort of combine these things. So if I come back into VS Code, and if I wanted to add a register in, so what I could do is do const, and we'll add a new value, let's call it N3, and we'll put that value equal to 50, for example. So N3 is equal to 50, and then what I'm going to do is just add N3 to the end of that. So it's going to be N1 plus N2 plus N3. We'll change the name to add three numbers. Just, I don't know why I'm insisting on changing the names, and then let's run that in our terminal again. So we'll change add three numbers. Well, let's run it first. So we'll run nodeexample.js. So it's going to return 80, which we would expect. Okay, let's just take a quick look at the bytecode that's generated. So the first thing is you see there's a parameter count of 3, which we'd expect. We pass two parameters in, 10 and 20, and we return one parameter back, which is the result of the function. So that gives us the 3 parameters. And then our register count is 2. So although we only introduced one new register, which is the constant N1, we are going to use a temporary register to be able to do this calculation. So it creates that under the hood for us, and that's why we have a register count of 2. Now, none of these instructions are new to you, but we're going to run through it on paper just so we can see exactly what's happening. So I'm just going to go back to the iPad for a second, and what we will do is we'll have an instruction column again. We will have our accumulator like we did before. We will have A0, which is the address that we had, A1, which represents our second parameter, and then we'll have R0, which represents the constant we created, and then R1, which is the temporary value that we did. So it's getting quite complicated, but that's okay. It's nothing that we haven't seen before. So let's run through this scenario. So from a begin perspective, again, it's not a real instruction, but we just want to see where we are. So R0 and R1 won't be set at this point. The accumulator won't be set, but the address 0 and address 1 will be, because they'll have the values of the parameters that we had. So A0 will be equal to 10 and A1 will be equal to 20. So the first thing, if we look at the screen, you'll see it's loading into the accumulator a small integer of 50. So that's LDA. We saw that in the last video. SMI 50. So our accumulator is now going to be equal to 50. A0 is still 10. A1 is still 20. R0 and R1 isn't set to anything. Next instruction is store whatever is in the accumulator into R0. So that's at star 0. So 50 is currently in the accumulator. So that's going to be stored in R0. And of course, R0 is a direct mapping to our constant N1 in the JavaScript that we created earlier. A0 is still going to be equal to 10, A1 is still going to be 20, our accumulator at this point is still going to be 50. And then the next statement is load into the accumulator whatever is in register A1. So let's put that in, eldar A1. So in A1 is 20, so let's put that into the accumulator. A0 is still 10, 20 is still A1, R0 is still 50. And then we're going to add whatever's in the accumulator to what, add from address A0 to whatever's in the accumulator. So at this point, the accumulator is currently set to 20 from before, and then we're going to add 10 to it. So that'll give us 30. So let's put that in. So add. And it's going to take the 10 from A0 and add it to the 20 there. So that makes 30, because remember, it's always storing the intermediary values. So that's still going to be 10, that's still going to be 20, and this is still going to be 50. So that's an add A0. And then the next statement is it's going to store whatever's in the accumulator, and it's going to store it in R1. So this is this temporary value that we said about before. So R1 is now going to be equal to 30. R0 is still going to be 50. A1 is still going to be 20. A0 is still going to be 10. And the accumulator at this point is still going to be 30. Now, the next thing that's going to happen is it's going to load into the accumulator whatever is in R0. So eldar R0. So the accumulator in in register 0 is 50. So the accumulator is now 50. A0 is still 10, 20, 50, 30. And then what we're going to do is add whatever is in R1 to the accumulator. So R1 is currently 30. The accumulator is 50. So that's going to make 80. Yep. And that's still going to be 10, 20, 50, 30. And then the final command is return. And if we look at that, 80 is in the accumulator. So that's what gets returned, 80. So that is exactly what is happening under the hood, and that's how parameters work. Okay, so that's quite a complicated example. And I think we've got a good idea of what happens with parameters. And to be honest, if I go back into VS Code, I could just keep adding parameters infinitum. So I could just keep adding N3, N4, N5, doesn't really matter. And we could add some more values, 10, 20, 30, 40, 50. We can hit save there. And then if I was to run that code again, N3 is already declared. Let's get rid of that constant, run it again. And then if we look at this, you can kind of see parameter count is 6. So I can just keep adding parameters, and it's just going to keep adding address registers as I need them to represent those parameters. Register count is still 1 because although I got rid of my constant, I'm still doing that temporary calculation. So it's going to create temporary registers for it. That's kind of how that works. Okay. If I want to simplify this, what happens if I not returning a value, right? It is perfectly reasonable. Let's remove all the parameters for a second. It is perfectly reasonable for me to return nothing, right? That's just a very valid scenario. Yeah. What if I don't want to load anything? What if I don't want to return any data? I can do that in JavaScript as a function. Well, let's see what happens. So if we go back to our code and we run nodeexample.jas, what comes back? Undefined. That's what we'd expect, right? If we have not initialized a value of any sort, then it's going to be set to undefined. And we see undefined come back. So that's what we would expect. Now, how is that represented as bytecode, though? So if I look at node-print bytecode and run that, what happens underneath there? We can see a new opcode, which is load into the accumulator, the value undefined. And you can see that there. So that is represented by opcode 0D. And then you see it returns AB. So it is returning an undefined value. So what have we learned from the last few videos? Well, I know we've only kept this at a function level. We've not looked at globals. We've not looked at multiple functions and closures and all that, but we've looked at sort of just function declarations. And we've kept it to number operations just now on purpose, and we'll cover strings and other primitives later on. But there are a few things that we can sort of learn from the last couple of videos. And that is, when we look at functions, every parameter is sort of enclosed up front, right? So we have a list of all the parameters that we're using, and the data is held locally to that function. There's no leakage, it's immutable. There's no leakage outside of the functions, right? So all our parameters are passed in, especially for the primitives, and they can't really be messed with, and they stay within that code, and they're declared up front. Every declaration we make is got a representative register as well. So, and that is both for lets, vars, consts, etc. And of course, it is also for anything that is temporary or intermediary. So we saw that when we did an n plus 1 plus n2, etc., then underneath the hood, the bytecode would need to do other operations and store that in temporary registers, and they're created and declared up front as well. So that's all within there. And then of course we've got our bytecode as well, which is all the instructions to perform the operation that we had, and it's all enclosed within that area, all the memory allocation that you need, all the registers that you're using. So it's very, very safe within that. But when you start to look at those functions in the future, when you look at your JavaScript code, I'm hoping that you're going to be able to look at that and say, oh, okay, this is an arithmetic operation, so it's going to happen on the accumulator. Oh, this is a parameter, so that's going to end up in A0 or A1, and I'm going to be able to load from those registers. And then, of course, when you start doing calculations, this plus this plus this, you're going to start to see these registers that are part of your function that you can actually start interacting with. So hopefully the JavaScript code will start to make sense. Now, in future videos, as I said, we're going to look at some more complicated ones. We're going to dive into all of the different primitives. We're going to look at things like objects, etc. as well, and so the non-primitives, and we'll get a bit more complicated. But hopefully you're starting to understand what's happening underneath the hood when you create this JavaScript code. Anyway, thanks.